Good morning. This is Dr. E. Manjoolatha, Assistant Professor of Mathematics, Annamacharya Institute of Technology and Sciences, Tirupati. In the previous sections, we discussed about mean chart. Today, we are going to discuss about range chart. This is range chart. This mean chart and range chart and standard deviation chart all comes under the variables, control charts for variables. So now come to range chart. R chart is used for controlling the quality dispersion or variability of the product. So here R chart is used for controlling the quality dispersion or variability of the product. Whereas in the mean chart is used for controlling the average quality of the product. So these are the differences between these two charts. Here we are taking some samples and regular intervals of time we compute the range and using that samples in the control charts. Okay. How to compute range chart? These are the steps to compute the range chart. First one is find the range capital R of each sample. Then calculate the mean of the sample range, that is R bar. Step 3, that is calculate the standard error of the range sigma R. Last one, the control limits. Our upper control limit is R bar plus 3 sigma R and lower control limit is R bar minus 3 sigma R. So sigma R is the standard error of the range R. It is convenient to compute UCL or LCR by using D4 and D3 values. These values we got from the statistical tables. When standard error is not given in the question, we are using these statistical values D4, D3 as provided in the table. The two limits, that is UCL and LCL, we are writing like this: D4 R bar and D3 R bar. R chart is used only for the relatively small sizes. For a large size of sample, we are using the standard deviation charts. Now, we are going to see a problem. Using mean and range charts together, we are seeing a same problem. We can see that X bar chart is the measure of the central tendency of the process, whereas range chart measures the dispersion or variance of the process. Since both the variables are important, we monitor a process using both the mean and range charts. To the first question. The following data show the values of the sample mean X bar and range R for 10 samples for each size is 6. Total samples are 10 and each sample size is 6. Calculate the values for central line and the control limits for mean chart and the range chart. Draw the control charts and comment on the state of control. This is the question. See, what they are given in the question is sample numbers. Total samples are 10 they are given, and mean of that samples they are given, and range they are given in the question. Now, here in the question, they didn't give the standard error sigma. So that we are using the formula, the statistical values D4, D3. Now, first calculate mean of the sample mean. and mean of the range, that is these two values. So total samples 10 and each sample size is 6, and total of the mean is 442 and total of the range is 58. So from this, mean of the sample mean is sum of xi bar by total samples, that is 442 by 10. So this is equal to 44.2, and R bar is sum of Ri by total samples, that is sum of Ri is 58 by 10 is equal to 5.8. So after getting these two values, x double bar and R bar, first we see the mean chart. Here the central line of is CL is equal to x double bar. That's we computed the value of that x double bar is 44.2, and the control limits are, that is UCL and LCL. UCL is x double bar plus A2 R bar, and LCL is x double bar minus A2 R bar. So simply the difference between these UCL and LCL is only the symbol. Now x double bar, that is 44.2 plus A2. A2 value is 0.483 and R bar is 5.8. How we get this A2 value from the statistical tables? See the statistical table. From the statistical table, these are the sample sizes, not the total samples. Each sample size. So we are going to see the values for each sample size. So at present problem we are having each sample size is 6. For that 6 you are having A2 value is 0.483. That is we keep here. This is 0.483. So from the statistical tables, you got the A2 value, and already you computed X double bar and R bar. So X double bar is 44.2 and R bar is 5.8. So, and doing the simplification, you get upper control limit is 47.0014, and similarly computing the LCL. So we know that all the values x double bar e to r bar, and substituting in this formula we get 41.3986 as the LCL. These are the values of the mean chart. Control line and UCL, upper control limit and lower control limit. Now I am going to see the graph. The graph, take the sample points in the x-axis and take the sample means in the y-axis. See in the question, this is sample numbers and these are the mean x bar. We are taking these values sample number values in the x-axis and mean values in the y-axis. Now we are going to draw the graph using these points. So 143, 249, like this we are taking the points. So 1 has 43, 2 has 49. See, 1 has 43, 2 has 49. Like this, we are draw the graph. Before going to draw the points, first you have to draw control line and LCL, lower control line or limit, and upper control line. These first we have to draw. See control line, that is CL. What is CL value? 44.2. First you have to draw this 44.2. And what is upper control value, limit value? 47.00. This is dotted line, upper control line. And come to LCL, 41.3993986. This is the lower control line. After that, 1 has 43 and 2 has 49. Like this, you have to keep the points. Then draw the graph and see the conclusion. Some sample points are outside the UCL and below the LCL. See, these are the points plotted outside the UCL and LCL. So, the process is not under control. That is the conclusion. If all the points lie inside these UCL and LCL limits, then only the process is in the control. Now, we are having 4 points plotted outside the limits. So that from using this mean chart, we said that the process is not in the control. Okay. For the same problem, we are going to see the range chart. So for the range chart, R bar, already you calculated that range, that is 5.8. And come to the UCL and LCL formulas. UCL is D4 R bar and LCL is D3 R bar. For each sample size, that is sample size is 6 and total samples is 10. So don't go for the total samples. When you are using the statistical tables, you have to remember that you are going to see for only each sample size. So for each sample size 6, you got a D4 value is 2.0004 and R bar 5.8. So that UCL of R bar is 11.6232. Similarly, LCR D3, that is 0. See the values in the statistical tables, D4, D3 values. This is, here you got D4 and D3 values. For each sample size 6 starts with 2. Here the value is starts with 2. Come to D4, D3 values. See D4 value for 2, 3, 4, 5, 6. So that each sample size, we are having each sample size is 6. For that 6, D4 is 2.004 and D3 is 0. Like this, you got the values. Come to the solution now. So, when substituting D4 and D3 values, you got UCL is 11.6232 and LCL is 0. Now, come to the graph. This is the range chart. Same sample points on the x-axis and in the y-axis, you have to keep the values of sample range. Sample range. And sample range means, see here in the question, this is sample number on x-axis and R values in the y-axis. Okay. and take the points as 1, 5, 2, 6, 3, 5. Like this, you are going to take the points. Okay. See the graph. Mean chart, range chart. First, draw the control line. Control line, that is R bar 5.8. See, this is control line, and upper control line, that is 11 point. This is the dotted lines 11.62, and LCL is 0. 0 means this is the x axis only. Okay. After that, you have to plot at the points 1, 5, like this. You have to plot the points. So here, what is the conclusion we are going to give here? All the sample points lie lie between UCL and LCL, so that we said that the process is under control. Okay, this is the range chart conclusion. Okay, now come to the second question. This is the second question. Construct a control chart for mean and range for the following data on the basis of users samples of 5 being taken every hour. Each set of 5 hours been arranged in ascending order of magnitude. Comment on whether the production seems to be under control, assuming that these are the first data. So each hour they are taking the samples. So total samples is this. 12 samples they are taken, and in this each sample the 5 sizes, each sample is 5. So you are tabulated the given data like this. So this is the samples, total samples. These are the total samples, and in each sample size is 5. So like this you have to draw the table and compute the total of the each samples, that is 347 you got. Like this you have to make it total. Last sample, 12th sample, and each sample sizes, this is 478. Now compute sample mean x bar, that is how you got the x bar, 347 by each sample size, that is 5. When you are dividing each sample size, you got x bar. Come to R, capital R, range, maximum minus minimum in the each sample size. In this, maximum is 87 and minimum is 42, so that you got the range of the first sample is 45. Similarly, you have to calculate all the range values of the given samples, and finally make the total, and this range total is 716. Now come to the, before going to the mean chart, you have to calculate mean of the sample mean and range R bar. So here x double bar is 8579.2 by 12. So here also total already we calculated a 716 range. By when you are dividing these total samples, you get the mean of the range, that is 59.67. And these are the table values. Here you are seeing each sample size is 5. So that for 5, A2 value this is D3, and this is D4 values. Now come to the mean chart. In this mean chart, the central line, that is x double bar is 71.6, and UCL, already you know these formulas. So compute the UCL from x double bar plus a to r, and substituting the values you got 106.91. And here LCL, just you keep instead of plus here minus, then you got LCL as 36.99. So first draw the x double bar value, that is the control line, and upper control and lower control, and keep the sample points in the x-axis and sample mean on the y-axis. Draw the points. From this graph, observe that when you are observing this, some sample points lie outside the control line and LCL, outside the LCL also. So that from the mean chart, what is the conclusion? The process is not under the control. Similarly, for the same problem, we are going to use R chart. So R bar, that's already we calculated. From these formulas, LCL and UCL, the values you got is 125.9, and D3 is 0, and this is central line, that is R bar. So come to the graph. Sample points take it in x-axis. These are the sample range, and draw the first CL line, that is 59.67, and UCL line and LCL line. So from this, here all the sample points lie inside the control lines. That means upper control line and lower control lines. So that we said that the process is under control. This is the conclusion. Okay. So from this, you completed the range chart. Last one is standard deviation chart. Standard deviation is also used to control the quality of dispersion. This means both are same. That is R chart and sigma, both are same. But the difficulty in the standard deviation is sigma restricts its uses in most of the industrial works only. But R chart is more popular and widely used. Also for the small samples, the range is sufficiently stable. So because instead of sigma chart, we are using the range chart for control the quality of the dispersion or variability of the product. So from this, we completed control charts for the variables. So mean chart, range chart, and standard deviation charts are completed. Okay, thank you.